In November 2011, a developer going by the name Marcus Persson, or widely known as Notch, released Minecraft. Since the game's release it almost has been a decade from the time of this video. Notch was responsible for developing the game in its early stages. He left in 2014 when Microsoft bought Mojang for $2.5 billion, which is impossible to turn down. He was proud of what he made, quoting, "I definitely think Minecraft is a freak thing. There's no way you could replicate it intentionally." Jens Bergensen was the co-founder of Mojang. He was the lead designer and the game has Easter eggs lit around to his contribution to the familiar design we all grew up knowing. Daniel Rosenfield, or C418, was a big part to Mojang's team. He composed most of the beloved Minecraft music with his distinct music style. He met Notch through an online forum. Eventually the two would collaborate to develop Minecraft. In its early stages, the game was coded in Java, which was Notch's preferred language, but for performance reasons the game now uses a combination of Notch's old Java code and some C++. Procedural terrain generation is a way to create data algorithmically as opposed to manually, making each world unique. The world is divided into chunks of 16 by 16 blocks, going from sky limit to bedrock. When you create a world, the spawn chunks will use a big mathematical function for each block in the view. This results to a chunk that is populated with blocks like air, dirt, and stone. When a user visits a new chunk, the function gets called. However, when visiting chunks that has been loaded before, blocks will not be destroyed or created, just preserved. When the player leaves the rendered distance of that chunk, the blocks get temporarily destroyed and get restored when players return to the chunk. This is done for performance reasons, since storing the entire world in one go is not a good idea. How does this complex function work? Well, let's start with the simpler one. The function takes three parameters: the x, y, and z coordinates. The function also has a list of blocks with some requirements to spawn. To keep this simple, it will only use dirt and air. If the y coordinates fall under 1, then the dirt block will be placed, otherwise it will be air. So, if you want to know what block is at 10, 3, minus 5, then just call the function and it will return air. However, this function is rather boring, mainly because it will generate a super flat world which is far from the diverse mountains, biomes and caves that we are used to. What this function needs is noise. A 1D coherent noise function is a good start, and don't get frightened, it's just a graph showing random numbers between a range. The key distinction is that they are always continuous, meaning they never jump, so they would have smooth edges. The result is always between a predictable range. For instance, here we have -1 and 1. They look random with no pattern. A better option would be to use a 2D noise map, which also looks like this. A map calculates the height of the terrain, which is useful for mountain peaks or the Y level of a cave. This noise has its own function. This function takes in the x and z coordinate to work out the y coordinate of that x and z. If the x or z weren't divided by 100, the mountain would be very narrow, and to not have the peak be one block high, we multiply it by 30. This is the new terrain we get for using this function. We can introduce other blocks in the main block function to make the terrain more diverse. Minecraft combines multiple noises at different amplitudes and frequencies to create more interesting stuff like caves, ores, and biomes. Some people believe Minecraft's PvP is simple, just run up to them and stab them, right? Well, not exactly. There are other factors in play such as projectiles, knockback, enchantments, and saturation. A sword is a handheld weapon that brings with it a lot of attributes, the key one being raw damage. A sword has a base damage which can easily be coded in, however there are many different variants of the sword. For instance, a diamond sword should inflict 7 damage, whereas a wooden sword should do 4. But it's not that simple either. There are other variables at play, one of them being armor. Armor does not give you more health, rather they make you more resistant to attack damage. Each armor point reduces 8% of damage, meaning a full armor set would reduce to 80%. With the addition of protection enchants and resistance potions, it is difficult to inflict any damage with a base weapon. The Sharpener enchant has been nerfed as of Minecraft version 1.9. It used to give an additional 1.25 damage per sharpness, but now for sharpness 1, it will add 1 damage, and any sharpness after that will only increase in damage by 0.5. This means the max enchanted sharpness sword will only inflict 10 damage or 5 hearts. This makes critical hits much more crucial with a random chance of inflicting a 0 to 50% damage increase. Knockback is also a big part of PvP. Skywars and Bedwars players use this to their advantage when going for void kills. There are 3 ways of optimizing your knockback hits: increase your momentum, decrease your enemy's momentum, and get the first hit on them. When you increase momentum towards the other player by sprinting, you will knock them back 2 times further than if you were stood still. This is also true when the enemy has no momentum, for example, when they are stood still or cancelling the sprint. There are a couple of ways of doing this: throw or fire any projectiles at them like snowballs or using a bow, poison them using potions, or make them run on a slime or honey block. As mentioned before, if you have the momentum over your enemy, then they will be knocked back twice as much. However, after the first hit, the knockback gets removed for the second hit unless you reset your the sprint again. This is known as W tapping. However, this means you need to stop your momentum entirely, which gives the enemy a chance to knock you back. Saturation is a status effect that reduces the need for eating. What most people don't know is that the saturation level is hidden. There is an additional 10 bars of hunger, which is invisible, and this is our saturation. This bar prolongs the time that our actual hunger bar gets depleted, meaning you can play more aggressive without worrying if you're regenning or not. Golden carrots give 3 bars of hunger. When eaten, however, it gives an additional 3.5 bars of saturation, whereas steak restores 4 hunger bars and 3 saturation bars. There are some basic criteria that needs to be met before a mob can spawn. Make sure the game difficulty is not on peaceful. Mobs only spawn in light level 7 or less. Most mobs can spawn on the surface or underground. However, there are some biome-specific mobs that spawn in certain areas, such as slime that spawn in the swamps or slime chunks. There are some other quirky mob spawns too. These mobs will still spawn if the game rule do mob spawn command is set to false, because they're part of structure generation. Things like iron golems, witches, and a black cart, 3 elder guardians, ender dragons, vindicators, and illagers. Mobs are broadly divided into 5 categories: hostiles, friendly, water creatures, water ambients, and ambients. Hostile mobs have a spawn cycle every game tick or 1/20th of a second. Friendly or water mobs have a spawn cycle of every 400 ticks or 20 seconds, meaning that the game is coded where hostile mobs are more common than friendly. However, bear in mind that hostile mobs can spawn in caves, whereas most friendlies cannot. Mobs spawn naturally within a square group of chunks centered on the player, a 15x15 chunk or 24x24 block radius. Where there are multiple players, mobs can spawn with given distance of any of them. However, hostile mobs that go over 128 blocks away from them do despawn. So for hostile, the mob spawn area is more or less limited to a sphere with a radius of 128 blocks. Mob caps are directly proportional to the total number of chunks eligible for spawning. This is the formula. These are the constant for each categories of mobs. This calculation shows that the chunk will be more populated with monsters, and you will see less of water creatures such as squids or dolphins. Structures are randomly generated and can be spotted around the world. Each biome has its own structure, and so does each dimension. The list of structures can be expansive, however these are the main structures that you would be most familiar with. Let's see how a village would have spawned. First, find a point in the world with the X, Y, and Z coordinates. Second, check to see if it's a suitable area by checking the noise map. If the village is underground, then do not spawn. If the village is in an inappropriate biome, then do not spawn. Third, generate the well in the center. Fourth, for each direction north, east, south, and west coming from the well, generate a random length of gravel path. Fifth, along the path generate buildings from a list of pre-built schematics. If it has spawned floating, then give it a cobblestone foundation. Sixth, populate the village with villagers. Other structures may go through the same steps, but with more or less parameters or chances of spawn.